This is the second video on section 5.2 covering logarithmic functions. And we are going to begin with these examples. This set of instructions says evaluate without a calculator. And I want you to remember the definition of a logarithm. So we go back to our definition. X equals b to the y is equivalent to y equals the log base b of x. So when we are determining the log base b of x, we are talking about the exponent that the base is raised to give me x. So in other words, log base 2 of 32 equals 5 because 2 to the 5th power equals 32. Again, if you think about this as an exponential, we would say 2 to the 5th power equals 32. So our answer is 5. Let's think about log base 9 of 81. We're thinking about the exponent that you raise 9 to. So 9 to what power equals 81? And that would be 2. Because 9 to the 2nd power equals 81. Log base 4 of 16 would also equal 2 because 4 to the 2nd power equals 16. So I hope you are beginning to see that the answer is the exponent that you raise each base to get this number here. If that's the case, log base 6 of 36 equals 2. Again, because 6 to the 2nd power equals 36. Now our last example is a little bit different because we're taking the logarithm of a fraction. So this says log base 3 of 1/9. Well, I know that log base 3 of 9 is equal to 2 because 3 to the 2nd power equals 9. This is a fraction, so my answer is going to be -2. And this, you have to remember that when you take a number to a negative power, 3 to the -2 is the same thing as 1 over 3 to the positive 2 power, which equals 1/9. So if you have a fraction here, assume that your answer to the logarithm will be negative. Now I have a couple of definitions for you. The first definition is the definition of a natural logarithm. And I put a box around the L and the N because there is a button on your calculator that says LN. That stands for the natural logarithm. A lot of students think this is a capital I, but it is not a capital I, it is an L. And the definition of a natural logarithm is that y equals the log base e of x is equivalent to y equals ln of x. So anytime you see the ln, which means natural logarithm, you will assume that we are talking about base e. The other definition that we need to be aware of is the definition for a common logarithm. Y equals log base 10 of x is equivalent to y equals log of x. So both of these buttons are on your calculator because we use them quite often in calculations. Again, when you see ln of x, we know we are talking about the log base e of x. When you see log of x without a base, you assume that you are talking about log base 10 of x. Now take your calculator and let's evaluate each of these to the nearest tenth. So all you do to find log of 8 is press the LOG button. The LOG button is just to the left of the 7. Press log of 8 and enter. And to 3 decimal places, that would be 0.903. Now if I ask you to find the natural log of 59, you'll press the LN button, which is right below the log button, right next to the number 4. LN of 59 is 4.07, and if I round to 3 decimal places, I would have 4.078. Our next example, log 58,310. I'm back to my LOG button, and I would have 58,310. And rounded to 3 decimal places, I have 4.766. The last one, I want to find the log of negative 100. If you try to calculate that, you should get an error. And the reason for that is we cannot take the logarithm of a negative number. You will always get an error if you try to take the logarithm of a negative number. Now I won't go through all of these, but let's go back to the log 8 equals 0.903. What that really means is log base 10 of 8 equals 0.903. And if you use your definition for logarithms, you would rewrite this as 10 to the 0.903 power equals, oops, that should be a 3, 8. Now go ahead and calculate that on your calculator. Do 10 to the 0.903 power. And you should get something that's very close to 8. We won't get exactly 8 because we rounded our number.